Here we go.
Okay, so good morning, good evening, good afternoon, depending where you are. Welcome to our short course. Before we start, I just want to show a very short video of our sponsors, the International Society of Photogrammetry and Remote Sensing Society.
And we like to thank the participation of our guests here. For me, it's an honor because here we have a person who was my advisor from the master and during my PhD. And I'm very proud to keep working with him all this time and to have here again in another symposium. And this session this afternoon for us here in Brazil will be a very pleasant session. And I hope you enjoy even more this afternoon, this here in Brazil, this Friday afternoon. And Veraldo, now can go.
Perfect.
Hi everyone. My name is Cheryl Rose Reyes, and I currently serve as the president of the International Society for Photogrammetry and Remote Sensing Student Consortium. I am very happy to welcome you all to the 6th edition of the IEEE GRSS Young Professionals and ISPRS Student Consortium Summer School this year. To start this event, I would like to present a bit about the ISPRS Student Consortium. We are the official representation of the youth to ISPRS. We link students, young researchers, and professionals worldwide interested in photogrammetry, remote sensing, and spatial information science to promote their scientific and professional developments. We advocate imaging and geospatial science for informed, scientifically valid, and technologically sound observations of Earth conditions and trends that lead to improved and effective decision-making. The consortium is also accepting registrations for individual membership. Please scan the QR code in this slide if you are interested to join us. I work together with members of the board of directors from all across the globe. Charles from Uganda is our vice president. Charmaine, who is currently in Ireland, is in charge of our newsletter. Mustafa, our social media administrator, is from Turkey. And finally, Sona from Azerbaijan is our web administrator. One of the major events that we host and coordinate every year are the summer schools. In 2019, the summer schools were in Uganda, Poland, South Korea, and Brazil. These summer schools provide international learning opportunities for students and young professionals at a minimum cost. This year, we scheduled 3 summer schools, but due to the COVID-19 situation, 2 of them were postponed, and we are sincerely thankful to the organizers of this summer school for making this an incredible virtual event. This is the first ISPRS Student Consortium Summer School that will be hosted online, and as you can see, we have an amazing lineup of speakers who will deliver lectures on remote sensing and machine learning. The consortium currently hosts the virtual rooms and the webinar series to provide our community with more opportunities to learn and interact with experts in our scientific community. The webinar series was conceptualized in 2018, and we have organized webinars on Google Earth Engine, computer vision, and machine learning. The virtual rooms is an initiative to keep the members of the consortium connected during this challenging time and to help them navigate our changing lifestyles. All the resources for the webinar series and the virtual rooms are available on our website and our YouTube channel. We also publish an official newsletter called Spectrum, which covers the broad applications of remote sensing, photogrammetry, and spatial information science, and welcomes contributors from diverse backgrounds and disciplines. We publish 4 issues a year, and our most recent issue is related to the current pandemic and the significance of geospatial information in tackling the impacts of this global health crisis to our society. The ISPRS Congress is one of the biggest gatherings in our scientific community, which is held every 4 years. The Congress hosted a virtual event for all papers submitted this year and postponed the in-person meeting for 2021. During the Congress, the consortium will be hosting a 3-day youth forum, which will feature the following activities: speed dating, technical sessions, a special session on women in remote sensing, photogrammetry, and spatial information science, a panel discussion, the General Assembly for our members, a student night, another summer school, and will co-organize a mapping party. The consortium would also like to invite you to nominate papers for the Excellence Award to be given during this event. Please scan the QR code for eligibility and nominations. Also, please visit the ISPRS Congress official website for updates. Finally, I would like to invite you all to join our communities on Facebook, Twitter, and to visit our website for all the information shared in this presentation. And again, I would like to invite you all to register as an individual member by scanning the QR code on the right. This is the end of my presentation, and I wish you all a meaningful summer school. Thank you very much.
Excellent. This was a welcome message of Cheryl Rose Rice. She's actually here attending this event, as well with the team of the Student Consortium of the International Society of Photogrammetry and Remote Sensing, in which, this event would not be possible at all. Right now, I just want to call the chair of this event here, João Lorenzetti, Dr. João Lorenzetti, a researcher actually from the Brazilian National Institute for Space Research, also known as INPE, to conduct actually this short course that consists of 3 lectures and then a discussion section. Welcome, Lorenzetti. Thank you a lot actually for accepting this task. And the room is now yours, and please present actually our speakers and give them a welcome message on our behalf. Thank you.
Okay, Veraldo, thank you very much. I should start perhaps saying hello, a good day, everyone. So my name is João Lorenzetti, and speaking for the Brazilian National Institute for Space Research, INPE. And I would like to start thanking the organizing committee for the invitation to be the chairperson of this session. I should say that my background is in physics, and I have a master's and a PhD degrees in physical oceanography. And I have been working with satellite data for oceanic monitoring and studies for about 4 decades, something like that. On behalf of the organizing committee of this event, I would like to welcome and thank everyone who I know is interrupting your activities to attend this summer school. Thank you for that. Yeah, I'm certain that we'll have a pleasant session, and I hope it will be of great usefulness, particularly to our young students and researchers who are at the beginning phase of their professional careers. I would like also here to thank our 3 speakers, Drs. Evlyn Novo, Dr. Jack Schuenemeyer, and Dr. Alejandro Frery, for having accepted to deliver their talks in the present event. Shortly, I will read a small curriculum of each one of our present our talk presenters. Okay. Today's session is part of the IEEE Institute of Electrical and Electronic Engineers, GRSS, Geoscience and Remote Sensing Society Young Professionals, and ISPRS, International Society of Photogrammetry and Remote Sensing Student Consortium Summer School Annual Activity, which is here promoted by the GRSS Brazil chapter and is jointly being organized with CERFA, the Brazilian Remote Sensing Symposium for the Defense Applications. This event is being organized by Dr. Veraldo Lisenberg, University of State of Santa Catarina, Brazil, and Dr. Rafael Paes, Institute of Advanced Studies, Brazil. I just wanted to state something which I think is very relevant, and that is, as all of you know, an important component of a scientific career is to make the result of one's findings to be known to the scientific community in the form of a well-written, clear, interesting, and acknowledged published paper. If you wanted to be a successful scientist, you will need throughout your career to score a fair number of good quality published papers. As for any other intellectual and creative activity, we can profit, we can learn, and we can be inspired by observing what others, more experienced and successful professionals in our area have done. Today, we will have three very experienced and recognized scientists sharing with us their knowledge and expertise on the subject of scientific writings. And I'm pretty sure we'll enjoy a lot and learn a lot from them. As already stated, our session will be organized into three 30-minute talks, okay? After the three talks, we have reserved a 30 minutes interactive session as a roundtable discussion session with all the speakers and with the participation of the audience. I would like to state that all participants can put their comments and questions to the speakers using the chat area in the web area of the event. So, without further ado, we can pass to our first talk with the title Concepts and the Structure of a Scientific Article, Hints for Being Noticed in Science. The speaker is Professor Jack Schuenemeyer from University of Delaware, United States, and Southwest Statistical Consulting. Dr. John Schuenemeyer is president of Southwest Statistical Consulting, Colorado. He has been a statistical consultant and educator for over 40 years. He received his PhD in statistics from the University of Georgia and was a professor of statistics at the University of Delaware for 25 years, where he is now Professor Emeritus. He was also active in the geology and geography departments. He has over 200 publications and a book on statistics in earth and environmental sciences. His major area of application is in geoscience. He is a fellow of the American Statistical Association and elected member of the International Statistical Institute. One of his great joys and privileges is working with students, which he continues to do so. So, Dr. Jack, please, we are eager to watch your presentation.
Thank you very much for that wonderful introduction. And let me get and share the screen, and we'll hopefully all this will work fine. Okay. Okay, we should be.
Click on the center of your figure.
Okay.
Yes. So,
Right.
Fine.
Okay, I think we've got everything, and I'll skip the first couple since our host here has done a wonderful job of introducing me. I'm certainly honored to have been invited here, and I appreciate the work that Veraldo and Rafael and all those who have organized this committee have done. And I've done this a bit in my life, and I appreciate how challenging this is. As I understand this, the talk and the PowerPoint presentation will be available to the participants here, and so I'm not going to actually read all of the parts of this, but I will make what I hope is appropriate comments. And and I have my email address on there. If there's something that doesn't get covered in either my presentation or any of the discussion follow that, I will be glad to communicate via email with all of the wonderful people that are participating in this. As our host said, the really key part of all of this is to be able to communicate effectively. It doesn't matter how good your idea is if you don't get it out to both the scientific community and in some cases the general public. It's not gonna go anywhere. And so the idea behind the talks here is to provide some information which will help you do that more effectively. So we're going to talk a little bit about journals, writing, and getting it published, and some remarks. Again, as I said, the important thing is obviously to have a topic, but for those of you who are writing thesis dissertations, too often people want to cram too much into it, and it's important to just pick your most significant contribution when you're getting something published. Selecting the journal is an important first step, because there's a whole host of journals even within specific disciplines. There can be 5, 10 different journals. So it really is important that you pick a journal that fits with your topic. And again, most journals have a preliminary audience, and so you want to match your interest, your topic with the journal. Obviously, journals are changing. Maybe in a decade or two, everything will be online, but that's a subject for another discussion. When I write, I start with an outline, and I think that's a critical part of the process. And my general outline is an introduction talking about relevant previous work and the contribution that I've made, and then providing a summary. The introduction is really a critical part of the paper. People want to know what you've done, and so you want to make sure you tell people what you've done, and that's important to do early on in the process. again, what I do when I start something is I look to see, where is it likely to be published, and then every journal has some different rules, regulations, guidelines, and so forth. And it's important to look at these and to know these when you start out. You can wait till the end of it, but then if you have, this is really it. A lot of this is sort of a pain, but it's important to do if you want to get something published, and you have to do this right. Again, most journals have many more submissions that they can ever publish, and so the better that you handle all of these little details, the more likely it is to get something published. So this is a really critical part of the whole process. And it would be nice if all the journals did everything the same, but they don't and they won't. So you gotta live with what you got. The important part of writing, as was previously mentioned, is the communication. There tends to be sometimes a tendency for particularly young people to try to impress people with how smart they are. That's not what you want to do. Again, you want to communicate. There are, if you can do it, the active voice is usually stronger. Sometimes, again, you have to look at the journal and see what kind of, what their format is and so forth. It's important to remember that many journals have an international audience, so you really need to watch that. A scientific paper, really, like a novel, is telling a story. And as I say here, good writing is good writing. Those of us who have read novels have occasionally picked up a novel where the novel starts and it goes into great gory details about all of the background. The trees are green, the grass is green, the water is blue, the sky is blue, et cetera, et cetera. And, you get totally bored and put the thing away. So you really need to grab people. And that's true in scientific writing as it is in the novel. Yes, you need to go into some background about the relevant previous work, but you really need to, in the introduction, and then as early as it's reasonable, tell people what you have done. I have to tell you just a brief story on writing. My dissertation advisor was a man by the name of Rolf Bardman, who got most of his, or some of his, at least, undergraduate education in Berlin. And I would go in to see him, and he had many graduate students. So I remember one particular instance where I went to see him, and it was fairly late at night, and he was reviewing one of the chapters in my dissertation, and it had red marks all over it. And he looked at me and he said, "Schuenemeyer, why can't you Americans learn to speak your own language and write your own language?" So I took him to heart, and it benefited me considerably over time. Again, it's important here to use words that are clear, understandable. And I know I've looked at some of my own writings, and I look at it and I say there's a bunch of words that could be eliminated, as I say in my examples here. Significantly more variables doesn't tell you much more than more variables. And obviously, if you can quantify that even more. But as you go through your writing and as you're reviewing your writing, take a look and see if there are some things that really don't contribute anything toward the paper, and get rid of those. I know some people who actually, when they're writing, sort of want to write, a perfect sentence. And the way I write, at least, is I just get something down. I mean, I obviously follow my outline when I'm writing, but I don't worry about making it perfect. That comes with the rewriting part. Again, you don't want to have too many words. You want to be as concise as you can. Obviously, you need to explain things carefully, but you need to be concise. Again, I think abstract, introduction, and summary are really critical parts of the whole process. I write the abstract and the summary after I'm done. But as I say, in the introductory process, you want to make sure that as part of the introduction, you tell people what you've done. And again, people are busy. You want to make sure that what you've actually done, what you've spent months, years doing, gets published and counts for something. Word processing editors, useful, as I say, but certainly there's a lot of things that even good word processing editors don't catch. So you have to read it and read it carefully. It's important to define terms that, that again, of course, depends to some extent on the journal, your readership and something. But that's important. As I said before, figures, tables, references have to meet the journal's standards. You really, you want to have somebody else read it and read it carefully, because all of us who've worked on a project and written and rewritten something a number of times think that, or feel pretty confident that we've got everything right, and we see things that actually aren't there. So somebody else will catch those and then do a read carefully before you submit it. It's also important to, as we think about writing, to be able to write for non-technical journals. I know here in the United States, there's been a lot of skepticism about the value of science, and if we want our work to have an impact, it typically has to go beyond the people in our particular research community. We want to get this out to the public. We need to write something to secure funding. We need to send progress reports. I have to do this pretty much on a monthly basis. So it's really critical that in your writing you need to to do more than just the very narrow sort of technical writing. So that's an important thing. I'd like to talk just a little bit about the submission to a journal, and these vary some extent from journal to journal, but it's important that you look at the rules, the guidelines, and know what they are. The letter of introduction that you write is really critical. A grammatical mistake, as I say, will get you an automatic rejection. I remember when I was a professor, I would be on hiring committees, and we would always have more applicants than we had positions open, and a great many of these applicants were highly qualified people. But the thing that we got them, the application tossed out automatically was a grammatical mistake in their introductory letter. I mean, we figured if they can't be careful about that, I'm not sure that what the research would be like. I say that generally these are two-stage processes. Usually the first stage is just an editor, an associate editor, deciding if it's at least maybe worthy of publication, and then they'll send it to a referee. It's important that you get take the comments from the referee seriously. You don't always have to agree with them. In some cases, you may not, but you have to at least respond in a prompt fashion. It's important to remember that even senior level researchers get rejection. So for those of you who are just starting out, that's certainly something that can happen to you. But the point here is basically sort of not to give up. Before I get into the summary, two just quick stories. I can remember my dissertation advisor telling me that he wished that he could write a paper that had no references in it, because this would be something absolutely totally new. Well, I don't think he or anybody else that I know of have ever gotten to do that, but it's a nice thought. The other story concerning getting papers refereed, there's a very distinguished statistician, died many years ago, and he was the invited speaker in an international conference. I believe it was in Chicago. And he was given this very flowery introduction and went out on the stage and got ready to give his talk. And he spotted the editor of a journal who he had submitted a paper to, and he asked them about the status of his paper. And the editor said, "I send it out to a referee." And the famous statistician said, "You what?" And he walks off the stage. There aren't many of us that can do that, and I think there are even few of us who would want to do that. So some of the key points are for young professionals, for students, be sure to ask for help if you don't understand something, how to do something. Certainly most of us will be glad to help. I'll certainly be glad to to help. The selection of a journal is really critical in terms of getting something published. Outline is really critical. Write, rewrite, follow the journal rules, make sure that other people read your submission, celebrate acceptance, and don't give up if you get a rejection. So that concludes my comments, and I'll be glad to participate in the discussion, and I look forward to hearing my colleague's presentation. Thank you.
Thank you, Dr. Jack, for an excellent presentation. And I'm sure our colleagues, students, young scientists will check your presentation carefully and will remember some of your advices. And I agree totally with everything that you said, okay? And perhaps one thing very important is to select, in fact, a proper journal. Because if you don't do that, you might have a very excellent material, okay? But then it might be, let's say, buried in this journal that nobody cares and very few people read. So by choosing a very proper and nice journal, this will give you a very advantage later in terms of promoting your paper. So this is, for me, it's a very important thing. Thank you very much for your talk. Okay, so next, I think we can pass on to our next speaker, which is, let me grab my annotations here. Dr. Alejandro Frery. Dr. Alejandro Frery's talk is called Handling References, Databases, and How to Avoid Plagiarism, Self-Plagiarism, and Other Questionable Writing Practices. So Alejandro, if you allow me, I'll read a little bit of your short, your curriculum here, okay? Dr. Alejandro Frery received the BSc degree in Electronic and Electrical Engineering from the Universidad de Mendoza, Argentina. His master degree in Applied Mathematics and Statistics from the Instituto de Matemática Pura e Aplicada, IMPA, Rio de Janeiro, Brazil. And his PhD degree in Applied Computing from the Instituto Nacional de Pesquisas Espaciais, INPE, São José dos Campos, Brazil. He is currently with the School of Mathematics and Statistics, Victoria University of Wellington, New Zealand, and holds a Washington Scholar position 2019-2021 with the Key Lab of Intelligent Perception and Image Understanding of the Ministry of Education, Zhejiang University, Xi'an, China. Sorry for my pronunciation of these words. His research interests are statistical computing and stochastic modeling. So, Alejandro, the floor is with you. Thank you.
Thank you very much for this invitation, for this great opportunity to talk to young researchers, young professionals. And well, here's the short version of the title. The original title is a little bit too long, so I made it short. Essentially, we will speak briefly about plagiarism and references and towards good practices in scientific life. Okay, so first of all, what I will present is essentially based on my own experience and on my own tastes and preferences. So there's no endorsement by IEEE, IEEE Geoscience and Remote Sensing Society or its affiliates. And I will mention a couple of software tools, and the developers, owners of these tools have absolutely nothing to do with my opinions. So let's start. So I wanted to start by reminding which are the cornerstones of a good scientific communication. And by good scientific communication, think of a master's thesis, a PhD thesis, a project report, a project proposal, or a paper. And we will focus on papers, on journal papers. The three main important, most important components of a scientific contribution are the ethical part, the state of the art, and making a clear point about the contribution to the right audience. And this was already covered by the previous presenter. About ethics, about the ethical part, essentially 5 points: authorship, plagiarism, data manipulation, conflicts of interest, and multiple submission. We will mention them briefly, and then we will go into plagiarism. About state of the art, where to make a good review of the literature, and about contribution and audience, I will totally skip that third component. So what can we say about the ethics of a good scientific contribution? Simple rules. Adhere to IEEE publishing ethics. IEEE has put together a set of brief, direct, concise, and very clear documents about these elements of a scientific contribution. What is an author? How about citations? How about data integrity? And about originality. So remember that when you submit a scientific contribution, be it a thesis, a dissertation, a report, a project proposal, or a paper, you put into work a complex and big machinery. And this machinery is mostly based on ad honorem work performed by highly respected specialists. So you are not invoking anyone when you submit a paper. When you submit a paper, you are summoning, you are drawing attention of the most highly respected researchers and specialists in the field. And their attention is really valuable. Their time is really valuable. So please keep this in mind when you submit a paper and value the time of these specialists at least as much as your time. So please do avoid wrong authorship. This is very delicate, and I won't go into the details, but if you want, we may talk about it later. Don't include people for their prestige. And don't exclude actual authors. IEEE has a very clear policy that defines what an author of a paper is. We can go through this later, but remember this. Mostly the first part. Do not include names, big shots, just for the sake of inheriting their prestige. It's not correct. Second thought, second idea, data manipulation. You should never select results, manipulate plots, manipulate figures, images. The data are the most valuable ingredient in a researcher's work. The data is the way nature speaks to us. So preserve the data, respect the data integrity. Conflict of interest. I will give you an example. Imagine you are working for a company, for a firm that has developed a new sensor, and you write a paper about the performance of such a sensor. You have to tell the editor-in-chief, your readership, that you are affiliated to such a firm because it's an important, it's a relevant piece of information. You must state every piece of information, and you should never hinder your affiliation, your ties, because in this way you are making a clear game, you're opening the game. Never, ever make multiple submission. If you submit a paper to a journal, wait until you have a decision or until you decide to withdraw it. But if the journal is taking too long, that is not enough for you to take the same paper and submit it to another journal. Don't you ever make multiple submissions, because it is easily caught. We are living in a world where everything is connected, and well, you will be punished if you make double submission or multiple submission. And finally, the topic that we will go into in a deeper way about plagiarism, which is essentially using another person's work without the proper citation, without the proper acknowledgement. So how does this start? The whole publishing game is based on something that I mentioned previously, which is the state of the art. One of the cornerstones of a scientific publication is the state of the art. And how do we define, how do we assess, how do we perform a good state of the art review? Well, a good review of the literature provides a right context for your contribution. With the right state of the art, you can say, our knowledge has reached this frontier. My contribution is this. And this is so very important. This is so very important that often papers are rejected because they don't make a clear statement of their contribution. So keep this in mind. This is very important. And a good review of the literature has three main properties. Completeness, in the sense that it presents the main ideas and where the current knowledge is. It is updated, in the sense that you have considered even unpublished work, and it is qualified, in the sense that you have used high-quality databases, top-quality databases, for instance, JCR journals, top conferences, high-quality books. Okay, these are the three main properties of a good state of the art. And the way to achieve a good review of the literature is using the concepts of a systematic review. What is a systematic review? A systematic review aims at answering a well-defined question by collecting and summarizing all the empirical evidence that fits predefined eligibility criteria. And I provide a citation, which is at the end of the presentation. By doing this, your review of the literature, your state of the art, will be verifiable. So anybody can check that what you said you did was in fact what you did. It is reproducible. So somebody else can take your rules, apply them, and will obtain the same results, the same list of papers. And it is also replicable in the sense that this same person who obtained the same papers you obtained can go further, make changes, and improve or continue the research. And why is this so important? Because it relates to the quality of your paper, and it relates to the two main topics that we will discuss, which are plagiarism and managing the databases of bibliography. So, how do we start a review of the literature? We need the most important element of any research project, which is a scientific question. What is a scientific question? A scientific question has three properties, again, three, magical number. The question has not been answered yet, so it embeds some originality, but not every unanswered question is a good scientific question. It also has to be answerable. It can be answered with the available resources. Which resources? Feasibility, time, means, and also it matters to the community. So a good scientific question has embedded originality, feasibility, and relevance. And also it helps a lot when the question is posed in such a way that the progress towards answering the question can be measured, can be followed. Checking my time. So how do we go from the scientific question to a review of the literature? Well, the scientific question is not something which is crystallized at the beginning of your project. The scientific question is a work in progress. It starts, for instance, with your advisor, or with colleagues, or from your own experience. Along with the scientific question, you must have at least one excellent paper to start working. At least one excellent reference to start thinking about the problem. Let's say you have N excellent references. The next step, define inclusion rules to add a new reference to your list of references. For instance, I am only interested in vegetation. Or for instance, I am only interested in software developed for certain application. So that gives you an inclusion rule. And also define an exclusion set of rules. For instance, I will discard papers which were published before 1970, or I will discard papers that were published in journals in the area of medicine. So define your question, have at least one excellent reference, and define inclusion rules and exclusion rules for adding new papers to your list of references. Then we can proceed with this algorithm, with this simple algorithm. Let me see if I can. Okay, I will use the cursor. We will define a procedure called collect. This procedure helps us find and select papers. The arguments of the procedure are a list of papers, at least one, the one with which you started, the papers with which you started, the inclusion rules and the exclusion rules. So what do we do in this procedure? For each paper in our input, think of one paper, make a list, the list of the cited papers. By this I mean, you have a paper and you check its references. You put all its references in this list. And then you also put in this list the citing papers. So those papers that cite your reference. You take all those papers and you put them on your list. Then you refine your list, excluding those papers that comply with the exclusion rules. For instance, you will delete all the papers that came from medicine, all the papers that came from biology, but do not comply with the inclusion rules. Okay? So we do this for each of the papers we started with. Our list L1 will grow, then we will have another list L2 related to the second paper. Often these lists have a big overlap. Don't worry, because when we have finished this loop, then we will return the union of the refined lists. And in this union, we won't have repeated papers. And this is the end of the procedure. But the program starts now. This was the procedure. This was the function. The program begins at line 8. And the program says, while there is a change in the refined list, call our collect procedure with the list and the inclusion and the exclusion rules. So you start with a paper. You make the list of all the papers the paper cited. You add to the list all the papers that cited your paper. You refine this list, and then you call the procedure with this list. Okay, then you go on this, and at some point your list won't change any longer. At some point your list will stop changing, and then you return the list. What can we say about this procedure? The procedure converges fast. Usually, in my experience, after 3 or 4 iterations, because we work in a limited knowledge scenario. There are not infinitely many papers which are relevant to our research question. Remember, we started by stating a research question. The first iteration is the one that takes the longest time. And where do you perform this? I do my research using almost exclusively Web of Science, because I am used to this tool. But it's a good idea to expand your view and to use Web of Science and Scopus. So these two platforms provide you with tools for performing such algorithm for the review of the literature. And remember, this is just one of the ways to perform a review of the literature. The way I present it is a way based on references. There are other ways. Illustrating the idea. This is your starting paper, your original paper, and I am using as example a fundamental paper by Professor João about noise reduction in polarimetric imagery, pulsar imagery. And this paper cites, I don't know, about 30 papers. The list of references this paper has includes, say, 30 papers. These 30 papers are the past. In a timeline, the past is the list of cited papers. Bring all of them into your list of references. But this paper, Professor João Lee's paper, has been cited, say, 70 times. That is the future of the paper. And you can have the list of the papers that cited your fundamental paper. Take this list, the complete list, and add it to your list of references. Then refine your list of references. Then go paper by paper in your list of references and perform the same technique. Soon And believe me, very fast, this procedure will converge. So, how do we handle such a massive number of references? Just to give you an idea, I am working on a technique for pulsar noise reduction, and I have done this, and I came up with 300 papers. That's a lot. I knew many of them, but not all of them. So how can we handle such a massive list of references? And how can we do it on our machine, not relying totally on the Web of Science? Well, you can export the list of references from the Web of Science in BBTeX format, because I assume you all use LaTeX and BBTeX, the best tools for scientific writing. So you export your list of references that has already been merged, that has already been refined. You export the list of references to BBTeX format, and you can import this list in, for instance, my tool of choice, JabRef. JabRef is totally free, 100% platform, and this is the look of JabRef. You see I have in my articles database almost 2,000 papers, and the oldest one is from the 17th century by Isaac Newton, and it goes up to 2020 and goes up to unpublished papers. And then with this, you can use keywords, you can search within the abstract, and you can, from this list, choose those papers that will be really useful for your review of the literature. But how do you decide which are the papers that will be really useful for your review of the literature? Well, there are other tools that can help you. For instance, I recommend QQuant in Portuguese, which is a software for systematic reviews. The software performs the reviews by keywords, by references, by topics. But if you don't want to use it, there are other ways to refine your review of the literature. But something which is very important is that a review of the literature, the state of the art, is not a list of references. A review of the literature, the state of the art, is a comprehensive analysis of the literature. It is different, a list from an analysis. So how do you start? You can start by a historical view along a timeline, and then you may group the articles by main advancements, conceptual viewpoints, greatest ideas, groundbreaking contributions. And a good work will make your contribution clear for your audience, but most importantly, it will be useful for you to understand the area in which you are working. And also there are tools. For instance, I use Voice Viewer, which shows topics and authors and papers as a graph, and the relationships. I cannot go into this. There are beautiful tutorials for Voice Viewer. This gives you a broad idea of the topics covered by your big list of references and how they relate. And there's also a even more advanced tool called Bibliometrics. It's a library developed for R that allows you to see your network of references. For instance, in this plot, which is, I think, very, very useful, the historical direct citation network, where you see individual papers and what they cite in your database. Okay, so it's interesting that you use a large database to see all the references and how they relate. This will help you greatly in making a good review of the literature, a good state of the art. Okay, so how do we avoid plagiarism? Essentially, you have to make it very clear what is yours and what belongs to others. You avoid plagiarism by using your own words. They might not be the most beautiful, the ones that employ the most sophisticated vocabulary, but use your own words. Because your task is telling about your work, not rewriting somebody else's work. And you will always have opportunities along your writing process to stress exactly what you need, rather than just copy-paste what others have done. And always cite the references that you have used, but providing a really clear context. I give you an example. A bad example of citing the literature is this. Previous works, Volpato, 2007, 2008, 2015, 2011, Frery, 2015, Frery and others, 2020. This adds nothing to the state of the art. This is a list of references. Okay, you have complied with the requirement of citing, but this is not exciting at all, because this is not the state of the art. How can you do this? How should you do this? Something like this. Professor Gilson Volpato, well, he's really important, he's fantastic indeed. His books are fundamental references, among which we mention Philosophical Aspects, 2007, The Structure of Scientific Publications, 2008, Logical Approach for Scientific Writing, 2011, Practical Guidelines, 2015, specifically for the remote sensing community. Well, I have written 2 papers about this, one by myself, 2015, and another with 2 colleagues, 2020. In the first, I discussed specifically how to make contributions to the geoscience and remote sensing community, and in the second, how to make a paper reproducible and replicable. You see the difference. Avoid providing a list. Make an assessment. Provide context to each paper you cite, but cite all the papers you use. Can you use somebody else's material? Yes, but you have to cite the source and making it clear when you make an ipsis literis textual citation. For instance, there is a famous paper by Moraes, 1948, and the opening sentence is just perfect. So why should I spoil it by putting my lack of talent between this sentence and the next reader? I can cite it, ipsis literis, but I have to make it clear that it is a literal citation like this. And we are running out of time. Remember that most journals use software for checking overlap. For instance, Authenticate is one of the most used software for this. Sorry. And Authenticate checks over journals, conferences, white papers, archive material, institutional repositories, and many other sources. So if you copy-paste, you will be caught. How to avoid this? Well, there is not such a thing as self-plagiarism. If you reuse a material of a paper that you published, you have to say it, because once your contribution is published, it is not yours any longer. It belongs to the community. It belongs to all the authors, and it belongs to the community. How do I avoid making this overlap mistake? I use Grammarly. Grammarly is a tool. I find it fantastic. It helps checking spelling, syntax, grammar, and style. And also, if you look at this right lower corner, it checks plagiarism in a few databases, and it helps a lot. And my concluding remark is that writing properly, avoiding plagiarism, keeps you from breaking the trust bond beyond you and the scientific community. Because when you break this bond, when you break this contract, it is very hard, if not impossible, to put it back again. So this is my contact. I am at your service. Whatever you need, I am there. Thank you very much again to the organizers.
Presentation, and I think you put for the students, young professionals, and the scientists in general, very important points, okay? Some of them, they might look as, well, you should do this, okay? But sometimes people forget about those points, okay? And sometimes this has a very important negative consequence for the researcher, and that might reflect in his career, okay? If a person is caught by doing plagiarism, his image as a fair and honest scientist it's very difficult to remove that stain, okay? So one must be very careful and complying with this ethical things, okay? And sometimes there are several examples in which people do plagiarism or not so much ethical things, not because they wanted to do it, but because they were naive, okay, when they wrote their material, and it's always a good idea to listen to talks like your talk that reminds people about all these important points. I'm pretty sure that your lecture will be read very carefully for lots of people all over the world, okay, because they contain several very important advices, scientific advices. Thank you very much. The next talk is going to be delivered by our dear colleague, Dr. Evlyn Novo. Her talk title is The Art of Writing a Good Research Proposal and a Novel Scientific Article, Insights for Contributing to Science. Dr. Evlyn Novo is a senior researcher at the Brazilian National Institute for Space Research, INPE. She has received her PhD in physical geography from University of São Paulo in 1984. She has been a professor at INPE's graduate program in remote sensing since 1985. At present, she is part of the Balancing Biodiversity Conservation with the Development in the Amazon Wetlands Bonds project, led by the Institut de Recherche pour le Développement, IRD, France. Sorry for my bad French pronunciation. This project is in collaboration with the research centers and universities from Europe, North and South America. Her research focus has been on the application of remote sensing tools for water resources management. So, dear Evlyn, the floor is with you for your talk. Thank you very much.
Can you see?
You can go ahead.
Yes?
Yes.
Okay. So I first of all, I want to thank the organization. In particular, I would like to thank Dr. Veraldo and Dr. Rafael for having approached me to talk about a little bit of this topic. While watching the presentations, I thought that there was lots of overlap between what I was going to talk and what have been said before. I think the presentations by Dr. Alejandro and Dr. Jack were very fine, and they covered almost what I was supposed to tell anyway. But I will do my best. I will try to give some hints and to share my 35 years of experience in trying to write proposals and to write papers and to make my students to learn how to write papers and have them accepted for nice journals. Okay, so I will, thanks God, I have emphasized my speech on the topic of writing good research proposals, because many times as a reviewer of research papers, I feel very sorry because I see that the paper cannot be approved because the experiment itself was not sound enough, the data are not good enough, the design, the way they manage the data are not good enough. So I think there are papers that are refused because they are not well written. But there are many papers that they are refused and they are not accepted, or they are accepted with major revisions because they have many flaws in their experimental designs. So I decided to focus on the topic of writing good research because why writing good scientific proposals is important. Because the first step to write a good paper is to have meaningful results based on a strong, well-done research experiment. And how do you know if you have a good experiment? Because you wrote a scientific proposal that you went to a funding agency and it was already tried out by peers, by people who are able to judge if you are proposing something that is good enough, okay? And so I think that that's the aspect I'm going to focus on, is because why you can have a very nice paper being accepted by a very good magazine, and which is then having many citations, etc. Because the innovation starts when the scientist has an idea, writes a proposal good enough to convince a funding agency that is worth investing in it. So if you have an idea, I think the first step to start your scientific career is to write a proposal and try to submit it to a funding agency. Because then you have an appreciation by this proposal will be reviewed. Many of the reviewers will be, this review will be based on criteria. I will come back to these criteria later. And then you can learn from your mistakes. You write the first proposal and it is not accepted. You receive from the funding agency an appraisal of what were the problems. And then you are able to go there to look up to your mistakes and try to study about it, to talk to people, to look for help, etc. And then you can have a good proposal, write a good proposal. And but then another problem is how to have good scientific ideas. And I think that apart from having the mindset of a scientist, which I suppose everybody who are in the graduate program or a young scientist, they have this mindset. One thing that graduate students and young scientists must follow closely is this scientific advances, not only in their fields, but also the advances in the analytical tools, because I remember, I am aware of that the statistics that I studied in the 70s have progressed a lot. There's a bunch of new methods that you have to follow. Otherwise, you will be using the same ways of testing ideas as you used back then. And sometimes the paper can be rejected because you are not using the most powerful tool for assessing the accuracy of your data, the soundness of your measurements, the accuracy of your calibration or your model, okay? And how to choose the best reference out of the overload of available papers. I think Alejandro gave you a lot of tools for doing that in a very fashionable, new way. But I think the principles that he presented are quite the same, because I would say that things that you have to judge to select your references is, first of all, journal impact factor. You have to look for papers in very good journals, because these journals, they will just leave the paper be published if this paper has none of the flaws that might get by in less important journals. It means that this journal of very high impact factor, we know that these journals, they are well ready by the scientific community, and if there is anything wrong with the papers, there will be some erratas or corrections or letters discussing the results, etc. You know, so because the people who read these papers are aware, are very serious regarding this, the accuracy and the reliability of the data. The other aspect to look at, it's the article citation index. For instance, you have to look for those articles that have been giving support for several other researches, because it means this article is in the mainstream of the topic, of the field. People, mainly if the article has been cited, or the author's research history is long enough to say that he has become, through his life, a kind of authority in that subject. So if you follow, when you are reading the papers, if you follow that lineage of the articles, you'll be able to reconstruct the field you are interested in, and it will be much easier to see the holes, the lack of information, the missing questions, the missing information, the missing knowledge that is still needs to be searched to complete the information, to advance the scientific knowledge. So I think that's one important point. And also the subject relevance history. Sometimes it's interesting because in some areas you have some, for instance, I'll give an example of the remote sensing area where I have, let's say, 46 years of experience. And you have fashions of papers, techniques. When a new processing algorithm is in the air, almost everybody wants to test this algorithm, and then all of a sudden, this paper of the guy who developed this algorithm becomes a hit, a trendy topic. And then, after a while, this wave of citations disappear. Because we, in science, as human endeavor, it suffers also the same behavior as the fashion in any area of the human activity. So you see that by following the subject relevance, you can see also if the question of, or the idea you are trying to follow is still an idea worth following, because there are some areas that all the answers have already been, there is not much left to kind of get the attention of the readers. So you have to pay attention on that as well. So this literature, to get the best references for doing a literature review will help if you organize your review by journal impact, article citation, authors, research history, subject relevance history. You'll be able to do a very good review of the literature. First of all, I think you have to do a systematic reading. What I mean by systematic reading, I think you have to organize the articles from the oldest to the newest, from a given author, research team or topic, to see what were the filled gaps, and what were they leave as open questions. Always in the end of a paper, you have a kind of future suggestions for future research, or things that were not completely closed, or what were the flaws of our experiment, etc., etc. That's something that you can have a paper which is oops. Which is not, sorry, which is not possible to read. I have to. It's not possible to do that. I'm trying to close my cell phone. I throw it away. So you have to do a systematic reading, organize the articles from the oldest to the newest, from a given author research team, to see what were filled gaps, and they leave as open questions. Examining papers, references to trace the theoretical background, and then to carry out the systematic writing. While reading, take notes of your thoughts, your doubts, your wonders, because sometimes when you read the papers, we just forget how to, we think, mainly the young, they think that they are aware, they will remember what they was thinking about, and sometimes they just put a note, a very short note in the paper, or a question mark, but they don't explain or take notes of what were the thoughts, the doubts, the wonders, what they were moved for the paper. And then I think one aspect which also helps to write a good proposal is to ask for help, because sometimes when we are younger, we have kind of a sense of omnipotence, that we think we want to be independent, and we want to know that we are able to do things by ourselves. But actually, we need a lot of help. And if you ask for help, we'll be able, by contacting peers and collaborators, to discuss the ideas, discuss our understanding. And after having discussed, etc., I think that one aspect it's very good for having our ideas to grow and to make sense, and to give ourselves time to let the ideas settle in our unconscious, because then they will ferment there, they will be very internalized, and then they will come back with those connections, like those that Alejandro showed among different papers, you know. So that's, I think, a very important aspect of the this phase of reviewing the literature. And then after having done all this job, you have to get back to your notes and see if there is any missing spot in the subject to be filled with your idea. Is this just an incremental contribution, or is it breakthrough? You were doing something great that was not thought before, and this has to be. You have to be very humble and criticize harshly your idea and see if it stands still, because otherwise you write your proposal and the proposal will be rejected as not good enough. So I think being a scientist and having a paper published, it's something that requires a very high commitment from the person. It's a profession that people must like to do it. It must feel pleasure of reading, of thinking, of trying out ideas, and then once you have you are certain that you have a good idea and you have ways to give a theoretical and a methodological background to your good idea. That is an idea that you'll be able to carry out and to provide good results and provide new informations and to contribute to science. Then you have, before writing it, you have to look for where to apply for funding, because you have several different agencies, and at present, most of the funding agencies, they have a kind of a template of how they want you to feed the information about your proposal. So you have to apply or to write according the different templates and according to different types of funding from the sponsor agencies. Generally, young scientists, they are funded by government funding agencies, because this is part of the effort to prepare human power for the scientific and technological development. So you have several government funding agencies that have programs for young scientists. The young scientist needs to know the several types of grants and their requirements. So seed grants, for instance, provides monies for young scientists to prove the potential of an idea, provide scholarship, fellowship, and project funding, but just for a very limited time, 1 year. So if your idea is very complex and you need much research, it's much resources, etc., and have many steps to follow, probably you won't be able to carry out your idea in 1 year, okay? And another type of grant that can involve young scientists are what we call regular grants, projects usually for further development of new ideas for a couple of years, 2 or 3, giving support for a research team, and including, for instance, a fellowship that the young scientist can use for postdoc or for visiting scholar or what else. and then to spend 2 or 3 years. And in this case, his idea has to be also accepted by the responsible for the research grant, because the seed grant, the owner of the grant is the young scientist, but for the regular grant there is a research who will be the responsible, and so the idea, he has also to convince this senior research or full research, etc., that his idea is worth supporting. Okay, I'm giving some examples of grants in FAPESP, and I will focus on the young investigators grants because I suppose most of you are young scientists. So I will talk about the criteria for assessing the research project submitted. So very strong criteria is that the project must be original, bold in the sense that it has risks. You have to do things that you are not 100% sure that it will succeed. You have to do something that is very competitive internationally, which is in the boundary of the innovation, and it's not necessarily the research, the sponsoring research does not demand results, successful results. The sponsoring agency demands that the experiment to test the idea is strong enough to show the flaws and to give, in the long run, ways to solve the problems faced in the project, in the original research. So I think that's a very important aspect, because most of us, and that's why I believe in young people, and I don't believe very much in, and it's interesting that when I was young, I used to believe in young people, and people would say to me that I thought about that. I was saying that because I was young, but now I'm older and I still believe that innovation is something that young people does, because they have not much to lose, so they can risk in the beginning because they are allowed to risk ideas, new ideas, test new opportunities, test new methods, test. So that's why the funding agency, they are not very much worried if the idea, the brilliant idea is really brilliant, and that if the idea can be improved. That's the important. The knowledge you get from trying out this new idea. Then you learn with your mistakes, and you are prepared, and you become resilient. You know what is really to be a scientist, because we have so many failures that it's not easy to sometimes to deal with. The second criterion is the research challenges if the research challenges are well formulated and situated in the state of art and in the existing literature. That's why the literature review is very important, because the advisors for the sponsoring agency will see if you really are in top of what's going on in your area, if you really know what are the issues that are being important to answer. So that's one very important aspect, is that the new idea has to be in the state of art of in the state of the art and in the focus of the literature, what is the most new in the literature. And the second criterion is if the methodology is adequate and is well justified, sufficiently detailed. Because sometimes I analyze lots of projects for FAPESP. And then what sometimes I see is that the theory is very well organized, it's very well done, but the methodology it is not clear, it's not detailed. I know that there is some aspect, for instance, we see that when our students make their research proposals for PhD or for master degree, etc., that there is a fuzziness in this phase, because we don't know so many things. We learn as we do, and we are make mistakes, and we try again, etc. But at certain degree, we have to know, and we have to try to understand the methods that we will be using. It's not just to cite sometimes, I do this according such a person. It's not enough. You have to show that you read the paper where the methodology is described, and that you understood what is the method. And mainly nowadays, mainly in remote sensing, where you have so many tools for processing, for producing maps, for providing results of types of forest, and types of geological units, etc. That one thing that is very interesting is that we should think that when we are describing the methodology, we have to not to talk about the tool, but to explain why that tool is important, why are the main issues, the main aspects, the main constraints that to have to or putting it better, you have to be very clear about how if that tool is adequate to our needs, and we have to know the tool, because sometimes we use a tool that is not adequate.
Evlyn, você passou dos 30 minutos já.
Okay. The criterion fourth, the results have the potential for expanding the knowledge in the research field, and therefore of having scientific impact with the publication, with potential for solicitation by the scientific community. So the potential, the publication potential is already assessed during the project evaluation. So many times the project is refused because the the results that the project will produce are not good enough for publication. Criterion 5, the research project can be carried out by proposing research and his team within the period provided for in the proposal, because you have to know that if you have a proposal, you have to carry out within a proper time. You can't just, you have to be ready to have a second plan if you plan B, if something goes wrong, because you have to finish the proposal and have the results by the time you have the grant given. Criterion 6, data management plan, describe the types of data to be produced, the ways of storing, preserving, and sharing. Because nowadays, data management and knowing what kind of data you'll be producing, how do you share the data? Because supporting a project cuts tax money, payers' money, and so the funding agencies more and more they want this money or the results be shared to society, so as many people can use the data as well to produce new knowledge. And 7, the team has adequate participation of undergraduate and graduate students. So one aspect very important is that when you are proposing, you are also selecting students for scientific initiation or grad students, etc., undergraduate students, to work with you, to share your knowledge, to share the results of your project, to aid to foster the human resources of your country. The academic record of a researcher is sponsored for the proposed project, so the PhD student has to publish a little bit before proposing a project, because he is publishing something that came from his advisor. But then, to become an independent researcher, he has to start submitting his own research and getting his own grants. So he can have a very good record of a publication, so as he can be his project. It helps to his project to be accepted. Criterion 9 is the project will nuclear a new research group in an institution that does not have yet a research tradition, or will create a new line of research in an institution with consolidated tradition. That's something that is given by the kind of call. Sometimes the government wants to foster research in a region, and then so he will try to apply to approve researches in not traditional institution, and some other times now. So that's why people need to read the proposals. In Criterion 10, the institutional and physical infrastructure offered by the institution in which the project will be developed is adequate, and there is an institutional commitment to the proposal according to program's rules. That means that if you have to adequate your idea to the infrastructure, because sometimes you are proposing to carry out a new idea, but there is no equipment, there is no lab, and there is nothing to help you. So you will not be able to develop this new idea in that environment. Write the proposal, search the good research laboratory where you can carry out your research proposal and get the approval. Write the first draft without being overcritical, just write down your ideas. Follow the sponsoring agent's proposal template to organize your project. and then how to write a novel scientific paper. I just did that as Alejandro finished his talk. Follow the wonderful talks from Dr. Jack and Dr. Alejandro. I'm done now.
Very much for your talk. And my brief comment, I think your talk gave a special emphasis to the idea of you only will be able to have a good scientific paper published if you have good results, important results, and you only have good results, important results, if you had a proper project put in the beginning. So the beginning of a good paper is a good scientific project, okay, that underpins the whole thing. So I think your presentation was mostly concerned about this very important topic, which is the beginning of the idea. So everyone who will publish a good paper later on certainly start with a good idea and collect the data in a proper way, okay, knew the theoretical aspects, knew the literature. So it's not a question of just writing, okay, but this writing must be underpinned, must be supported previously by all these steps. So thank you very much for having stressed these points to our audience. And I think we just finished the 3 talk session, and we should now to go immediately to the next part of this session, which is the roundtable discussion. And for that, we have in the chat area several questions that were put by the students and people who were watching the talks, okay? And many questions. And it's somewhat even difficult to choose which one to start. But I would take the liberty here to start with the Professor Jack. We have this person from Minas Gerais state, and he has a very tricky question, which is the following: should a person be totally neutral when writes a paper, or in some ways have space to put his personal view of his personality, as we can say, into the writing, or should be like a like a automata thing, totally unbiased, totally neutral? How do you? I don't know if it was clear, the question.
No, I think it's a clear question, and I think it's an important question. And I'll give you an example of why it's important, because in the United States now, as well as in many other countries in the world, there's a big controversy on what steps should be taken to avoid the coronavirus, wearing the masks and the social distancing and so forth. And I've been engaged a little bit on the periphery of some of that, but the scientific evidence is clear, and I think that the persons that are writing this material are not putting their own view in it. So I think you don't want to do that. You don't want to, because I think that basically sort of destroys the credibility of what you're doing. On the other hand, I think it's quite appropriate for a scientist to say, look, there's just overwhelming scientific evidence that if you do social distancing, if you wear a mask, that will reduce the chance of not just you, but other people that you come in contact with becoming ill. So it's two things. One, you can write a scientific article and, have available, use the best science that you can. At the same time, you can be an advocate for good scientific results.
Okay, thank you. The next question I would like to address, Alejandro. We have a question here from Luciana Rita Guedes for Alejandro. I will read her writing. I would like to ask Professor Frery about his algorithm for literature review. Is it published in some journal or conference proceedings? I thought it is impressive. Thank you very much for this. So, please, Alejandro.
Thank you very much, Luciana. In fact, no, it hasn't been published. It is just a projection of my own experience. And as I mentioned, it is just one of the many ways in which you can perform a systematic review of the literature. This one starts with papers. As Professor Evlyn Novo mentioned, there are other ways, by keywords, by authors. There are many, many ways, but I think this way of making it formal, of putting it into paper, helps a lot. In particular, it helps reproducibility and replicability. Thanks for your question.
Thank you, Alejandro. Is there an interesting point raised by by this person, which is the following? He worked in satellite, but with the software that is needed for that satellite to work properly, okay? So then it comes to the point, where would be the best journal to publish this? Should this be in a, let's say, satellite instrumentation journal or in a software journal? He tried both. And in one, they complained that in the satellite engineering journal, they complained that it was too much software. And in the software journal, they complained that it was too much engineering. So I would like to address this to Evlyn. Okay, Evlyn, how would you give your advice to this person? What to do when your research is in between, let's say, two very different topics, okay? How to avoid this type of problems. Do you understand?
I know. I don't know, but I think that nowadays you have multidisciplinary magazines. For instance, there is nowadays there is Frontiers of Science. It's a magazine that accepts multidisciplinary papers in between areas, because nowadays you have more and more projects involving people from different areas, mainly in this area of global change and biodiversity and impacts of land cover, land use change, etc. You have people from different areas of fields of research. So I think you have to look for those new magazines. There are new magazines with this scope. They are not for technical, not for theoretical area. I think that was the question. I don't know if I answered the question, but I think there are new magazines. I can't remember exactly the name of the magazine, but I have been reviewing papers for this kind of for this new magazine. It's, let's say, it has been around the next 3 or 4 years, and there are many very interesting papers because they mix things from human dimension and also from technological aspects, using remote sensing, using geotechnology, etc., but applied to sciences, to health problems, to things like that. So I think that's a way of looking for.
Yeah, it's something like, please, Dr. Jack, please, go ahead.
Yeah, I wonder if I could just make an additional comment to that. I think that, number one, an awful lot of research nowadays is multidisciplinary. I know, and some of the multidisciplinary journals have been around for a while. I can, one example is the International Association for Mathematical Geosciences, and there are articles that would not normally be published, would not be published. Getting a little noise here. There are articles that wouldn't be published in a statistics journal or in a geoscience journal, but the contribution is still very, very worthwhile because it's an advance that needs to be published.
Okay, thank you for your comments. And I would ask you to give your comments, Jack, to another question that was directed to you, is that in your talk, at some point you said something like you need to define terms as necessary, and a student asked if you can comment a little bit more what you really meant as define terms as necessary.
Sure, be glad to do that. In any technical paper, there's obviously a lot of terms, and what the writer has to do is basically sort of look at the audience. For example, in a in say some statistical journals, the term Markov theorem would be used. Now, this is something that either most of the people who read it would know, or it would be relatively easy to find. Another term that might be used is, say, something called Cantelli's inequality, which is much less likely to be known to the audience. So you don't want to define literally everything, because you have to make an assumption that the readership, and again, it gets back to the point of knowing who your readers are, but that people will know that. But there are some terms that are used so infrequently or so highly technical that people wouldn't necessarily know it, and those are ones that should be defined. So that's what I was referring to.
Yeah, thank you. And as a matter of fact, we just published a paper, and this was the use of SAR, polarimetric data, to study wave breaking in the ocean, okay? This phenomenon of wave breaking that normally people see on the beach, okay? The wave breaks, but that happens on the open ocean. So it is in between these two fields of people who are really interested and totally interested in wave studies, but they are not SAR knowledgeable, okay? But the paper is about the use of SAR data for that. Yeah. That comes to this problem of the terms that you need to define so that these two communities, they know what you're talking about, okay? So when we submit the paper, we use this term sigma naught or sigma zero, which for the community working with SAR data is something that you think you don't need to define, okay? Because you're assuming everybody knows this, okay? But when we got one of the reviewers' comments, okay, it was clear that it was from this ocean and wave studies, and he asked, could you please define what is this sigma zero? I don't know what this thing is. So it's interesting because we assumed it was something that it was so clear that we didn't, it was needed, the definition. But then he convinced us, okay, for the sake of this other community, it was worth very shortly defining the term because it was really an important term. And I would like to listen to Alejandro's comment on this. Have you ever had this type of problem, Alejandro?
Essentially all the time. Because my research is for those who do applications, I am too theoretical. For those who do theory, I am too applied. But my guideline is usually I submit to those journals which I read most, because those are my source of inspiration, my source of relevant problems. But in the case that was specifically mentioned in the question, a paper that has lots of computer science and lots of remote sensing or geosciences, there is a fantastic journal called Computers and Geosciences, where I myself published the description of a new algorithm for inverting covariance matrices in polarimetric data. So very specific. But that was the perfect journal for it. Essentially, the journals that you read most are the ones where you should want to publish.
Okay, Alejandro, thank you very much. Evlyn, now I have this question that was directed to you by Murilo Schramm da Silva. I will read it. It goes like that. I would like to ask Evlyn, what's the importance of keeping publications in high and low impact fact journals?
What's the importance of keeping
publication, not, as I understood, not only in high, but high and low impact fact journals? I understand that perhaps this is trying to hear what you have to say. Not only sometimes we cannot publish papers all the time in high impact, but sometimes in not so high instead of, let's say, low, okay, impact journals.
I think that we have problems of, we publish in low impact journals as well, because we are pressed many times for having publications. Our students, they have to publish so as they can defend their doctoral degree. And sometimes their papers, because out of the time, out of the difficulty of, because one thing that I haven't talked is that sometimes in Brazil, mainly in Brazil, for instance, you write a good proposal, you have the money the proposal accepted, and then the money is just contingency. You don't have the money. You have just a virtual aspect of the money. So many times you have to adapt, and you have a student that have to do something and have to get his degree, etc. So between the ideal and the feasible, there is a nightmare, a hell in between, you know. So, but I think that individually we have to try to do the best. We have to try to do what is the best thing, so as the science can advance, because without with just bad science, you won't have improvements in the knowledge, you know. So one thing is to know that the reality sometimes doesn't allow us to publish a paper in a high standard magazine, because the paper doesn't have the qualities to be published. But many of my students, one advice I give them is that even if the paper, in my view, is not good enough, they have to submit to the high standard magazine. Then they have the paper refused, and see the comments, use the comments, the criticism to improve the paper, and then try a little, a lower rank, and then if they succeed, there is a gain, you know, because sometimes the eagerness to publish is so high that you just publish everywhere just to have it done, just to have on paper published, and to have your quote of publications set, you know. And sometimes the problem is that the low ranking magazine, it won't be read for almost anybody. So it won't be cited. And sometimes you will be the only one who knows the paper. You know, so what's the point, you know? So I think we have to aim to do papers for publishing in not the top of all the magazines, but we have to try to learn with the criticisms, and then try again. Sometimes the magazine says, oh, if you do all the major revisions, you can submit again, and then you submit again, and it's published, you know. So I think there is, I think we are sometimes very sensitive to criticisms, and I think that's the problem. We don't like to hear no, and then we try to be safe by submitting to a magazine that is not so good.
Okay, Evlyn, thank you. I'm gonna have a provocation for Dr. Jack to hear his comments. In sometimes you have you work in a project, okay, which is methodologically somewhat complex, okay, involves lots of people, technicians sometimes. You have a complex data acquisition. For example, in oceanography, you have to put buoys in the water that transmit the data through satellite links, and then you have the satellite people that collect different data that complements the buoy data, and people of the ship that are collecting situ data. So you have a very, very complex data acquisition, okay? Then you have this enormous data set, and you start working with the data, not data that you personally collect. You collect part of the data, okay? But you have to rely to data that were collected by other people. And some of these people, they really sweat and sometimes risk their lives even to collect the data if it's in the ocean, okay? But then you come to the point of writing your paper that uses this data set. The point I'm raising here is, should we include as much people as possible as co-authors, because they had this important task of helping to collect the data? Or at which point we just acknowledge and thanks at the end of the paper these people? It's for me, it's kind of a difficult cutting point. I mean, should we put all these people as co-authors, or we just state thank you, Mr. blah 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 blah, for collecting data? And how to solve this tricky thing? You understand what I mean, huh?
I understand what you mean, and it's a tricky proposition, and it's sort of interesting because some disciplines do it differently. For example, if you look at medical journals, I just recently looked at one, and there must have been probably 20 co-authors. I mean, fortunately, this was written in South Korea, and the people had very short names. If they'd have had names like Schuenemeyer, why they'd have never gotten anything in the journal. But it is a serious problem. My general feeling, what I've usually done is provide acknowledgments to the people who have submitted or actually gone out, and in some cases very, very difficult environments to collect data. I think for some things that are done, laboratory type experiments, the person who collected the data might be more involved in the actual research. So there I would list them as a co-author, but I agree, it's not an easy question to answer.
Yes, Evlyn, would you like to comment? Have you already had this type of ethical thing problem?
But I have my point of view is that the paper is an intellectual effort. So people has to have an intellectual contribution, not only as like provider, as data provider. For instance, in our field, we have many people who collect data, and sometimes they provide the data. And if you want to use the data, we invite the person and ask the person if the person wants to collaborate or say, help to write, discussing the ideas, etc. Because otherwise there is no point. And many times the person says, for instance, I have a PhD student that I'm not in the paper she published, because one of the papers she published, because she had a co-advisor, and it was a part of the paper which I couldn't give any help. I didn't collaborate with the paper. Even being the advisor, I collaborated in the entire, because it's a multidisciplinary area, but that part of the research was advised by the co-advisor, and she put my name there just because I said, no, because I think you have to be part of the paper. You have to discuss the ideas. You have to share, to write, to correct, to interact, to give ideas, to discuss the ideas, to know about what you're doing, not just to discover you published a paper.
No, and I should perhaps comment that presently, most of the journals, high-quality journals, they request that the main author, tells what was the role of each co-author. And in some journals, they want you to specify in different areas what was the contribution. It was on the conception of the idea, was in the methodology, was in data processing, was etc., etc. Alejandro, you have something to comment on that?
Yes, I have faced this like a problem. People who bought the computer where I was working, but with the project, this person was furious because he or she was not an author of my papers. And there are, but it happens. And also, as Evlyn mentioned, people who collected the data sometimes feel the owner of every intellectual contribution that comes out of the data, and that is not correct. My rule of the thumb is the following. Will the person be able to present the paper and defend the ideas? If yes, well, we may consider this person as an author. Because
good
in
idea.
order to be an author, the person has to participate in the outline, the project of the whole experiment, drafting the article, reading the article, agreeing with everything, even with the references. So, but it's tough, mostly for young researchers. They are pressed
intellectually to the article.
Yeah.
And there are some this weird cases, okay, in which there is a very I'm not saying important, but he controls the money of this place, okay? So he's a very powerful guy. And so people put his name in all the publications, and we see that it's totally out of question that the contribution of this person intellectually to that paper was real, okay? Because the contributions are in totally different areas, okay? But the guy is there, you know that, because he controls the money. So this kind of co-authoring thing is something that stains, and it goes into this ethical problems that Alejandro was talking about. And but we see this, okay? And I have another perhaps final question here, because we're almost running out of time, by Murilo Silva. His question is the following. Some papers in high IF journals, impact journals, do not make the methodology clear enough to allow reproducibility. How to clarify this problem? Who would like to comment on that? Jack?
Well, yeah, I'll take a quick shot at it. I think that's an important thing, because if one of the things that we want to do as scientists is be able to use the information that has already been presented, and if we can't get the gory details, we're not going to be able to do that. It doesn't have to be in the paper, but at least at a minimum, the one or more of the authors of the paper should have that posted on their website, make it available to make it available to the general audience. Now, in some cases, you've got some problems with confidentiality of data or ownership of data, and there's nothing you can do about that other than to note that.
Okay, thank you, Jack. As we go around for a finishing comments, I would go to Alejandro. There is a question for you from José Marcato Jr. So as your final, you can use this answer and have your final comments. Could you please talk about the role of the preprint?
Yes, well, this has been some problem in the past because authors like to show their work before it is published and also to establish an area. So many people use archive, I do, and now we also have TechRive, the IEEE version of archive. And then comes the problem, okay, I already have my manuscript on archive. Can I submit it as a paper? Yes, you can. But you have to tell the editor that you have already put this paper on archive or in an institutional repository, because there are rules to follow. I have seen sometimes, a few times, papers that were rejected out of the bat by the editor-in-chief, saying this paper, this submission has 100% of overlap with this archive paper. That is wrong. That is wrong from the editor-in-chief or from the authors that didn't disclose this information. But most journals, I would say, I risk to say, all the journals I read, they allow you to put your paper on archive before submission and then to update it along the review process. So it's, for me, personal opinion, it's an excellent practice.
Okay.
But you have to
beg your pardon?
But you have to tell the editor-in-chief.
All right, thank you. As we are over our 30 minutes allotted time, I will ask each one of you for your final remarks, short remarks, okay? And please, Evlyn, could you use your time for your final remarks?
Well, I'm very happy. I was a very bit worried about, because mainly when I was watching their talks and I think that I have nothing new to talk, but I'm very happy because I could learn a lot, and I think there are those tools Alejandro show and the talk about how to write a paper, etc., very well explained. I think I learn a lot, and I think the students also have profit from. So I would like to congratulate Veraldo and Rafael for putting this kind of event, because students sometimes are have a bad time to know what to do to become successful, not so successful, but a good scientist.
Okay. Thank you, Evlyn. Thank you. Alejandro, your final remarks, please.
Thank you very much. I would like to make rather general remarks. I would like to remind everyone that being a scientist is essentially being generous and ethical. So being generous means answer every request you have and try to publish your findings because they are important, not because you are pressed to publish. Think of the time it takes to read through a paper and to discover it is worthless. Avoid this. Share your findings because they are good. And be ethical. adhere to all the rules of ethics, because we are in a relatively small community that aims at making a big impact. So remember this, and good luck in your scientific career.
Thank you, Alejandro. Jack, please, your time.
Good science and people working together are making this a better world, and I appreciate all of the participants in this program.
Thank you very much. So I would like again to thank you three presenters for your talks. You guys brought very interesting and important points to our community, and especially to the young professionals and students, and I'm sure they will take this a long time in their careers. And I would also like to thank Dr. Veraldo and Dr. Rafael for having invited me to be a moderator for this session. And for me, it was a pleasure. I learned a lot. And now I must say that we are finishing with this school, okay? And I thank you, everybody. And I'm gonna pass the floor to Veraldo and Rafael for their final remarks. Thank you very much.
Thank you, Professor. Actually, we would like to thank you all again for these brilliant lectures and for this remarkable Friday afternoon, at least here in Brazil. And thank you very much. Veraldo, do you have something to say? Are your audio?
Okay, yeah. Thank Lorenzetti, Evlyn, Alejandro, and Jack actually for sharing actually your precious time actually and your experience for this young generation. Yeah, I have no more words than saying thank you tremendously actually for this nice opportunity. And yeah, we have also next Thursday a series of three more lectures with related with hyperspectral remote sensing and UAVs to finish, let's say, the program. And tomorrow, Saturday morning, we have another tutorial. Rafael, if you can just explain it.
Yeah, for tomorrow morning, we have this third tutorial inside the scope of GRSS Young Professionals. Everyone is invited to participate. It will be in Portuguese. However, you can address our questions if you want in English, and after we can also make the presentation available in English too. And it begins at 9:30 in the morning, and I believe who already subscribed in the platform will receive the link and the information by email. Okay, so on my side is all of it. I'm very happy and glad to see all this brilliant discussions, very good questions, and that's it. I just like to wish a good afternoon and good weekend for everyone. And tomorrow
Okay.
we continue.
Thank you.
Perfect.
Bye-bye, everybody.
Yeah. Bye-bye.
Goodbye, everyone.
Yeah.
Have a nice
Thank you
weekend.
all.
Nice
Sure.
friend. Bye.
You
Bye-bye.
tomorrow.
Let's just take a picture.
Goodbye.
Yeah.
I I already sent the slides to Veraldo.
Okay, okay,
okay.
perfect.
Okay.
Let me just
Okay, bye all.